1.5 is on factoring by grouping. Factoring by grouping is a method that usually we will use when there are 4 terms. 1, 2, 3, 4. When there are 4 terms and there's no GCF of every single thing and there's no way to factor it, this method works fairly well. So the way it works is very simple. We are going to figure out what the GCF is of terms 1 and 2, meaning if I look at these 2 terms, I'm going to circle it here in red, and I were to try to figure out what is the GCF of these 2 terms, I bet you know that the GCF of those 2 things is 5s squared. And if you were to factor out a 5s squared from these 2 terms only, you would have 2s plus 5 inside parentheses. Yes? Do you agree with that step? Now what I want you to realize is that we're adding this 8s plus 20 to that red group. That this is still, even though this is multiply right there, there's still addition in this problem. It is not all multiplication. And our goal will be to get it to be all multiplication. So what we're going to do is we're going to do the second part of this, which is factor out a GCF from terms 3 and 4. That is these 2 things. Third term, fourth term. Is there a GCF of that? What is it? It is 4. What's left behind is this. 4 times 2s is 8s. 4 times 5 is 20. This blue group is being added to the red group. So it is not all multiplication. We have multiply here, but we have this plus sign in the middle. So technically this is not completely factored because it's not all multiplication. What we can do, and the hardest part about this is the B step, but most of you will figure this out once I do it. If the groups match, does the 2s plus 5 match with the other 2s plus 5? Are they the same? Yes, they are. Factor the group as a GCF, meaning since this is multiplying a 2s plus 5 and this is multiplying a 2s plus 5, they're both multiplying a 2s plus 5. Let's factor out a 2s plus 5 from this group and from this group and put it out here, pretending that there's parentheses like this. We're going to put it outside. What would be left behind? It would look like this. 2s plus 5 times 5s squared plus 4. This is now all multiplication. It works. We can check it by foiling. Look at what happens when I do 2s times 5s squared. That makes 10s to the third. What is 5 times 5s squared? 25s squared. What is 2s times 4? 8s. What is 5 times 4, which is 20? This foils to be that. Now, the O and the I are a little bit backwards compared to what we've done before, but it worked. It takes something that was all addition, and we were able to turn it into multiplication by doing a GCF once and doing a GCF twice. Fairly simple. We're going to try that on this example. Number 3. The first thing we should always check is there a GCF of everything? Is there something that goes into all 4 terms? Nope. So then, since there are 4 terms, we're going to go into factor by grouping. And so, factor by grouping, I'm going to look at these first 2 terms, and I'm going to look for a GCF of just those 2. If you know what the GCF is of those 2 terms, say it out loud. What would go inside parentheses if you factor out a 3x squared from these first 2 terms would be a 2x plus This, even though these two things are multiplying, we're still adding things. So it is not factored just yet. In order for it to be factoring, we have to have all multiplication. Now, you're adding this 2x plus 3. I want another group of 2x plus 3. I know this is going to be somewhat difficult. That's one of the reasons why I had you write this down. The two groups must match. Sometimes you will use an invisible 1. I want this to multiply to be 2x plus 3. What if I factored out a GCF and this GCF was a 1, like 1 times 2x and 1 times 3? Does that equal that blue thing that's up there? Do these two groups match now? If you get the two groups to match, you're doing it correctly. If at any time you cannot get the two groups to match, you are probably doing something wrong because they all factor. I'm just going to say that to you at this point. If the two groups match, what we're going to do is pretend that these are the GCFs, and we're going to pull that out. That goes in one parenthesis. Do you know what goes in this parenthesis? You can check. This times this is that. 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 And what you should always do at this point is there a GCF inside? Is there a GCF inside? Is there a difference of squares? If not, there's your final answer. Is this okay? Is it simple? Good. Because the examples that I have picked for you are the ones that they try to step it up a notch. They try to make it harder. How do they make it harder? Number 7, number 8, number 11. Those are the ones we're going to do. How do they try to make number 7 a little bit harder on you? There's a GCF of the whole thing. Is there a number that goes into all 4 of those things? Yes. What number goes into all 4 of those things?
4.
So I'm sure that if you factored out a 4, you would get 8x to the third plus 2x squared plus 12x plus 3. Let's see if you agree with that. So far, so good. So we're using GCF factoring, but we still have 4 terms. So now at this stage of the game, we need to try factor by grouping. I'm going to circle first term, second term, and look for a GCF of that. And because we're going to be factoring some things out, I'm going to change this parenthesis and this parenthesis into a bracket. It's going to make me stay a little more organized. Bracket, bracket for a moment. And the GCF of these two terms would be a 2x squared. I believe what should be here is a 4x plus 1. Now out of terms 3 and 4 that are being added to that thing that I circled, still being added. It's not all multiplication yet. I'm looking for a GCF of terms 3 and 4. How about a positive 3? Which would leave us another parenthesis, 3 times 4x plus 1. Do these two groups match? So once again, we can factor these things out and see what's left behind goes into another group. Now at this point of the game, I'm going to factor out a 4x plus 1 multiplied by this pops out, and this pops out. What's left behind? I don't need brackets anymore at this point because the 4 is multiplying this, and it's all multiplication. You should double check. Is there a GCF of this? Is there a GCF of that? Just in case. You should also look to see, are there a difference of squares? Because that might happen eventually, the harder that they get. Two more examples. Number 8. Completely factor your final answers. I say that because sometimes you're going to have to keep going. Is there a GCF of everything?
No.
So let's go ahead and then look at just terms 1 and 2. Since there's 4 terms, we're going to try factor by grouping. We're going to make a group out of the first 2 terms and factor something out of it. What should I factor out? How about an x squared? I hope what's left behind is a 2x plus 5. Do you agree? And then what happens is we're subtracting an 8x and a negative 20 from this red group. It's subtraction. It's not multiplication yet. Because we want a 2x plus 5 to be the group, because we want that to match up, maybe we should factor out a negative from these 2 things over here. A negative something or a something. A negative 4. Now a negative 4 times a positive 2x is a negative 8x. A negative 4 times a positive 5 would equal a negative 20. This blue group is being subtracted by the red group. It's not all multiplication. So to get out of that, we are going to have to look for a GCF of that common group, the 2x plus 5. And it shall multiply. What goes in the other parentheses? Say it out loud. Yay! Are we done? Nope. Because there is something else that can still factor. Do you see it? This is a difference of squares. What does it factor to? To what? One group of addition, one group of subtraction, x plus 2 times x minus 2, or vice versa. X minus 2 times x plus 2 is the same thing. Is this factored completely? Yay! And sometimes they will do that. By the way, these are the minus ones. When you don't see it, if you forget to factor something, it's either a minus 1 or a minus 2 depending on how you show your work on the other parts. Last example. Number 11. I don't see a GCF of all 4. So since there are 4 terms, I'm going to do a GCF of the first 2. And I think that GCF would be x to the 4th. Three x squared plus a 5. This says negative 3x squared minus 5, and it's not going to match unless I pull something out of it to make it match. How about a negative 1? It's still subtraction though. It's not all multiplication. We're going to need to factor out something. So let me see. I'm going to factor out a GCF of this 3x squared plus 5. What's left behind? Are we done? Can something factor further? What? What is x to the fourth minus 1 factor to? I heard somebody say x squared plus 1, x squared minus 1. Don't forget the 1 pointer. Some people forget this 3x squared plus 5. It just disappears. You're going to make sure you bring that down. It just stays with it. Yay, are we done? Does something else factor? What else factors? Can this factor, this x squared plus 1? The x squared plus 1, is it the difference of two squares? Difference means subtraction. This is the sum of two squares. We cannot factor the sum of two squares, only the difference. So this is the only piece that breaks apart. Everything else stays the same. Does anything else factor? This is your final answer for number 11. We're going to stop your notes right there.